Good day everyone. This is my presentation for EMC 221, and so our topic for today is points in 3D space, vectors for direction and movement, and matrices for geometric data manipulation. So let's tackle our topic for today. Points in 3D space. So, points in 3D space are fundamental to understanding geometry in the real world. A point in 3D space is defined by a set of three coordinates, which is the x, y, and z, and these coordinates represent a location along the x, y, and z axis. For example, the point 3, 4, 5 is located 3 units along the x-axis, 4 units along the y-axis, and the 5 units along the z-axis. So points are used in computer graphics, engineering, and physics to define positions in a three-dimensional environment. So that is the points in 3D space. So let's tackle the second one. So vectors for direction and movement. So vectors are essential tools for describing direction and movement in space. A vector is a quantity that has both magnitude and direction. In 3D space, a vector is represented as vector equal to A, B, and C, where A, B, and C denote its components along the x, y, and z axes. Vectors can be added, subtracted, and scaled, making them useful for calculations involving movement and force. Consider a vector which is the vector is equal to 2, 3, and 1. It describes a movement of 2 units along the x-axis and 3 units along the y-axis and 1 unit along the z-axis. And vectors are used in physics to represent forces and velocities, in graphics for rendering, and in navigation systems. So next is matrices for geometric data manipulation. Matrices play a crucial role in transforming and manipulating geometric data. So a matrix is a rectangular array of numbers arranged in rows and columns. In 3D graphics, matrices are often used for transformations such as translation, scaling, and rotation. And a transformation matrix can rotate a point or object around an axis. And by multiplying a point or a vector by a matrix, we can perform complex transformations easily. Matrices are vital in computer graphics for animating objects, in robotics for kinematics, and in data science for handling multi-dimensional datasets. To sum up, points in 3D space, vectors, and matrices are powerful mathematical tools used across various fields. They help us model, analyze, and manipulate spatial data effectively. Whether you're working on graphics, engineering, or physics, these concepts are foundational to understanding the complex world around us. So that's all for today. Thank you for listening and watching our topic for today.